So, the term AI engineer has been thrown around a lot lately, right? Well, it's finally moved past being just a buzzword. It's now a really crucial discipline, especially if you're a senior software engineer trying to build the next generation of apps. But what does it actually mean to be an AI engineer? Let's get into it.
The best way I've found to think about this is with a simple analogy. Think of ML engineering as building the engine. It's all about fine-tuning the model, optimizing the weights, making that engine as powerful and efficient as possible. But AI engineering, that's about building the whole car. You're worried about the steering, the brakes, the user interface, the safety systems, the entire experience that gets a passenger from point A to point B. One is a critical component, for sure, but the other is the complete working system.
Okay, so if we're building the whole car, what does that actually take? How do we go from just having a powerful engine to creating a product that's reliable, useful, and, safe? To really answer that, we need to look at a more formal framework. To build that car, you really have to understand that the modern production-level view of AI engineering is all about blending three key interconnected areas. And here they are. You've got software systems, that's your APIs, your security, your classic ops stuff. Then you have AI capabilities, think LLMs, RAG, prompting. And finally, human context, the user experience, trust, safety. Now, traditionally, an ML engineer lives deep inside that AI capability circle, focused on the model. But the AI engineer, you live right in the middle. Your job is to be the integrator, the one who brings it all together at that intersection. Let's just quickly break that down a bit more. As an AI engineer, you are responsible for the absolute bedrock of software systems. We're talking about building solid APIs, keeping latency super low, and locking down security. Of course, you're also harnessing all the power of AI capabilities like LLMs and retrieval-augmented generation. And this is the important part, you're doing all of that in service of the human context. You're trying to design a great UX, build trust with your users, and actually solve a real problem for them. All right, that's enough theory. Let's make this way more concrete. We'll use a case study. Imagine we're building a support agent for a fictional airline called Skystream Airlines. This should make the different roles really clear. So at Skystream, you'd probably find 3 different roles working on this. A data scientist might dig through flight data and deliver a dashboard showing baggage loss rates. An ML engineer might take a bunch of internal documents, fine-tune a model, and hand over a model weights file. But you, the AI engineer, your deliverable is the thing that's actually running, the application that customers use, that connects to live databases, and that has to respond in seconds. And this right here leads to a huge mindset shift. An ML engineer might see a problem with the chatbot and think, I need to retrain the model to get another 2% accuracy. But an AI engineer sees that the real problem is that the bot is quoting an outdated pet policy from a 2-year-old document. And the crucial insight is this: you don't solve that with more training. You solve it by engineering a better system, like a smarter RAG pipeline that always pulls the latest, most correct document. It's a pure engineering solution to an AI problem. So how do you get into that engineering mindset? Well, it really comes down to a few core principles that guide how we build AI systems that are ready for production and that people can actually count on. Okay, first, you have to accept that probabilistic is the new deterministic. LLMs are, by their nature, unpredictable, so your job is to build rock-solid guardrails around them. Second, evaluations are your new unit tests. A quick vibe check isn't going to cut it. You need to build automated test suites that hammer your system with tricky edge cases. And third, and this is a big one, latency is a UX killer. A perfect answer that takes 15 seconds to generate is a failed product. You have to engineer for speed using things like caching, streaming, and being smart about which model you use for which task. When you put all of this together, it begs a pretty important question. When you're building one of these complex AI systems, where does all your time and effort really go? I think the best way to visualize it is with the AI engineering iceberg. Everybody sees the stuff on top, right? The cool model, the clever system prompt. That's just the tiny tip sticking out of the water. The real work, the vast majority of it, is the massive engineering infrastructure hidden just below the surface. And we can actually put some numbers on this. The prompting, the model selection, that little tip of the iceberg, that probably accounts for maybe 10% of the total effort. So what about the other 90%? That's just pure, hardcore engineering. It's building the robust, scalable, and reliable system that makes that fancy model useful in the first place. So what's actually in that hidden 90%? Well, it's everything from setting up and managing vector databases for your RAG system to building those comprehensive eval suites we talked about.
It's implementing caching layers to keep things fast, instrumenting everything with observability for tracing and debugging, and of course, ensuring strict data privacy and security. This is the real work of AI engineering.
So I'll just leave you with this one question to think about. It's pretty easy to get a model working in a notebook. Anyone can do that. But the real challenge, the absolute core of AI engineering, is being able to answer this. Your model might be ready, but is your system ready for production? Thanks for tuning in.